Okay, thank you, Unia. Is it a problem for you if I don't send the link? I don't know. Do I always have to send you the link? I think you know by now, you should be knowing by now that you just enter the course and you log in to the to the session. Okay, let's wait for 2 more minutes. Yesterday we have talked about the sorting. We have discussed the selection sort, okay, and the performance of the selection sort, and we said that the efficiency of the selection sort is on to the power of 2 or on squared, okay. It's a bit. This means that if I have a number, an n size of records, then it will take the power of 2, the square of this size as time to finish my algorithm or to finish my processing time. Okay. So, for instance, if I have n, if the n is the size of the records, if I double now my data set or my records to n, then it will take now 4 times. If I have 3 as the triple size of my data set, which is 3n, then it will take 9 times to finish my processing of the sorting. Okay, I'll start recording now. I think I have. As you can see here in my PowerPoint, in the insertion sort, you are as if you are dealing with a total new array. So I'll give you here an example. Assume you have the following array. It starts with 11, 9, 16, 5, and 7, and you want to sort this array. Okay. In the beginning, just ignore this dark blue color. Okay. This is your array, and in the insertion sort, you will deal with your array as if you are building at a different new array. So you will first take the element of the position 0. So you will always start with position 0. Now you have what in your hand? You have 11 in your hand. So that's it. If you look at 11 itself, 11 on its own as a single number is sorted. It is sorted. Why? Because it's only one number. Okay. But now, so I will keep it in my position 0 as it is. Then I will add to the new array that I'm building here a value for the position 1, which is a of 1. So what value do I have now? I have the 9. Now I have 2 elements in my hand. I need to compare them. If 9 is greater than, if the value at position 1 is greater than the value at position 0, which is the previous position, then is smaller than the value of the position 0, then please take the 9 and insert it at the beginning. So, and this is what happened when I started to add a of 1. So I compared the 9 with 11, okay, and now 9 is less than 11, so it's inserted at the beginning. Now I have two elements in my hand that are sorted, okay, and the rest what the rest of the array is 16, 5, 7. So now I need to add a value for position 2, okay. So I need to add a of 2. What value do I have now? I have 16. Now I will compare 16, okay, with the value in the previous position. So I will compare 16 with 11. I will find that 16 is greater, so it will stay as it is. Then I compare 16 with 9. It will actually still it's less than 9, so it will stay here. Then I will add now a of 3. So what values do I have left? I have here the 5. Okay, so now I add the value of 5. When I compare it with 16, it's less. With 11, it's less. With 9, it's less. So I will insert it again in the beginning. Alright, then comes the 7. The 7 is less than the 16, is less than the 11, is less than the 9, okay, and is greater than the 5, so it will be here, there is one line missing, so the 7 will be inserted here after this will be the 7. assume that this is the final value will be 5, okay, 7, 9, okay, 11, and then 16. So this is after sorting the whole thing, okay? So do you understand what the insertion sort is now? Do you understand the concept here? Everyone's following? Okay. Right. So the two main things that I'm doing in each step is what? In each step, in the very beginning, I always take the value at position 0. So this is with me in my hand. Then in the second step, I start adding values to my array. Okay. So when I start adding this value, I compare first with the value in the previous position, like I did with 911. If it's less, then please insert it at the beginning. If not, then keep it as it is, etc. Okay, so I always compare the value that I am inserting or I'm adding with the value before, and then I make my decision. So here we go. If we implement this, how does it look like? Is Noor here? Because she had a question yesterday. I wanted to add something to her. Not yet? Okay. Alright, then I will go now to my Eclipse here. And I have here my class called Insertion Sorter. Again, the same thing that we're always doing. I declare a class called Insertion Sorter. Okay, since this class will be sorting an array, so I will declare a variable of type array. So private int square brackets a. Okay. Then I have the constructor, which has the same name of my class. This constructor initializes my array, so it takes as a parameter an array of type int. Okay, and then I pass this array to the array that is defined as my private variable here in my class. So a is equal to an array. An array is the parameter that is passed to the constructor. Okay. Then I have my sort methods. Okay. Now we'll go step by step in through the code, and then we will trace it together. Right? Now, the code, as you can see here, I have a method called public void sort. This method sorts the array which is called A. Okay? Now, in the beginning, I'll have a loop. Remember, when we start, I will start first always by saying that the value or the first at the first position or the first element, okay, I keep it with me and it is sorted because it's just a single value. So I start here in looping on my array from which position? From I, not from 0. So for int I equal to 1, I less than a dot length, and we said the length returns, the length is a property in the array that returns the length of the array. Okay, and I plus plus. Then we declare a variable, it's called next. Okay, this variable takes the value at position I. Takes the value at position I. So in my case here, for instance, where is the PowerPoint? 11 was at position 0. I'm starting from which position? I'm starting from position 1. Okay, and I'm now declaring a variable called next that takes the value in 1, which is I equal to 1, huh? And I store it in next. What do you expect we do afterwards? Just forget about the code now. We said I will take this value, okay, whenever and I will add it to the 11. But before adding to the 11, I will compare it first with the 11. The 11 is at which position? It's at the position. It's at the previous position. So if this is I equal to 1, then this is at I minus 1, which is 0. Is everyone following? Everyone's following. Okay, and this is what we're doing here in my code here. So I store now the value the next in a variable called next of a, the value of a of I, and then I store the position in which I am right now. So I'm in which position I am in position number 1. So I store it in another variable called j. So now I'm storing the value and the position. The value is stored in next and the position is stored in j. Then I now do my loop and comparison. Now while j is greater than 0. Why greater than 0? Because as long as j is greater than 0, then I am not in the first element, alright? And if a of j minus 1, do you see, is greater than next. What is the a of j minus 1? It is the value in the previous position of the array. Is greater than next. If it's greater than the value that I have stored in next, then please switch them. Please get the value of next and insert it at the beginning. So then we have then a of j is equal to what? A of j minus 1. Is this step clear for everyone? Is this step clear for everyone? Huh? Okay, I will repeat. No problem. Again, I said what I'm doing here again in my PowerPoint. We start. Where from do we start? We start from the second position, because in the first position, which is position 0, I have the value of 11. This is just one number, and one number is already sorted by itself because this is the only number I have now. But when I want to add to complement or to build now my array, so I will take the next number. The next number is what? Is at which position? At the second position, which is I equal to 1, right? So now I have 11 in my hand. Now I go to 9, which is at position I equal to 1, okay, which is at position 1, and then I insert it next to the 11. But before I insert it next to the 11, I'll compare 9 with 11. 11 is right now where? It's at position 0. 9 is at right now where? At position 1. So I compare the value at position 1 with the value at position 0. Position 1 is equal, where I is equal to 1, and position 0 is I minus 1, which is 0. If 9 is less, so if the value in the position of I, which is 1, less than the value in the position of I minus 1, which is 0, then please put the 9 at the position of 0. Is this clear? Is this clear? The story is clear? Okay. Now just translate this as I just said it in the code. Here we go. Now I'm starting from where? I'm starting from 1, not from position 0, because the 11 is already with me. Then I take, at this point, I store the value at the position of I. In my case, this is what? This is 9. And I store also the position, which is here. This is 1. So I store the value of 9 in next, and I store the value of I, which is 1, in j. Okay? Then, what's the next step? I need to insert it next to the 11 now. Now, can I insert it right away, or I need first to make a comparison? Yes. So one condition, in order to be able to insert it next to the 11, you need first to do a comparison. What is the comparison? First, make sure that you're not at the beginning of the array. So if j is greater than 0. Okay, and if a of j minus 1, you see, a of j of minus 1, we're referring to which position now? A of 1 minus 1, which is a of 0. So if a of 0, which is here the 11, greater than the value of next, which is 9. So if 11 is greater than next, then please put the 9 at, put the 9 where? Then please put the 11 at 1. So move it up. So then this means that a of j is now equal to what? A of j minus 1. So a of j, which is a of 1, now has the value that is lying in a of 1 minus 1, which is 0. So a of 1 now is equal to A of 1 is now equal to 11. You see here? We just have put the 11 here. Everyone's following so far? Everyone's following so far? Okay, perfect. Now what do we do? J minus minus. J minus minus. Now J was what in the first round? Huh? It was, up till now, it was 1. So when I will say minus 1 means what? It means 0. Okay. Now can I proceed with the loop? No. The loop will stop now. I have reached the beginning of the array. Now, what value should I put at position 0, which is the J now? Remember, J is now equal to 0. Okay. So what value shall I put now? It's the next, which is the 9 here. So what I did, I have first compared the 9 with the 11. I found that 11 is greater. Then I have shifted it and put it instead of at the position of 9. And when I reached the value, the position 0 again, I have taken the value that I have stored in next, and I have put it here, which is the 9. So 9 now is at position 0, and at position 1 I have put my 11. Now, is it clear now, everyone? Is it clear? Everyone? Okay, perfect. So now I can continue. Okay. Now this whole thing will just keep repeating. So now again, what do? We move now to the second I. Okay. Second I means that I plus plus. So I am now at which position? I'm at position 2. Okay, then I will store again the value at position 2, and I will store the position 2 in my J. And as we always do, I compare the value at which I am currently staying with the value in the previous position. If it's greater than, then I will switch it. If not, then no problem. Okay, etc. Until we finish the whole array. Now, is the code clear, everyone? Is the code clear? Would you like me to trace the code with you? Do a simple example. Okay, how many yes do we have? Would you like to trace the code? Okay. I'll give you a simple example here. Let's remove this part. Okay, and here J equals, that's it. Okay, now imagine we have the following array: 17, 5, 3, and 9. Okay, now I will have a loop over this array. Now this array is not sorted, and I need to sort it. I said what? In the beginning, we'll start with at 0. We know that this element is, since this is a single element, so I will ignore it. It's already sorted by its own. Now I will take the second element and add it to it, which is 5. So I need now to the 5 to add it as well, as if, just imagine, as if I'm building an A dash. Okay. Which is now, so now in the beginning I have now 17. And now I need to add what, girls? I need to add the 5 to it. Okay? So, now, when I compare the 5, I compare it with what? I compare the 5 with the value in the previous position. So, now if 5 is at position what? بسرعة قولوا لي. 5 is at position what? 1. I will compare it with the value in position. Yes, exactly. طيب يبقى what shall we do now? So we'll start now from I equal to 1 because I have already the 17 with me. This is already sorted. So int I equals to 1, I less than a dot length I plus plus. So I is now equal to 1 here. Now int next equals a of I. So I'm declaring a variable called next in which I store the value in the that is stored in the position of a of I. A of I is what? A of 1 is what? What's the value for next now? Huh? A of I is a of 1, so the value now is it's 17. Again, I'm starting from where only and Dalal? I'm starting from I equal to 1. So a of y is what? Huh? It is equal to, sorry, oh, you're right, I'm sorry. I was looking at the second array. Yes, you're totally right. It's 5, exactly. Okay? Then I will store also the position in which I am staying. So the j is equal here to 1. So far is okay. Now I will do my loop. As I said, I will compare now the 5 with the value, alright, in the previous position. So let's do it. I have a loop. Make sure first that you're not in the first position. So while j is, because if I'm if I'm the first position, then I'm at position what? I equals 0. Can I compare this value with the position before? So 0 minus 1? No. So I need to make sure that I'm not in the position 0. So while j is greater than 0, and now what is my condition here? If or while a of j minus 1, so a of j of minus 1 is equal a, which value here? Huh? Give me a value. A of j minus 1 is equal to what here? 17. بالظبط يا دلال. 17, exactly. Sorry. 17. So a of j minus 1 is now equal to 17. Greater than next, which is, we said 5. So if 17 greater than 5, okay, do the following. Make a of j, which is what? A of j is what here? It's a of 1. Equal to what? To the value in a of j minus 1, which is the 17. So now what have we done? So far a of 1 is equal to 17. Now j minus minus. So what I did exactly, I have moved the larger value up. Okay? When I mean up, I mean towards the tail of the array. Okay? And then j minus minus. So j is equal to what now? Huh? Exactly. 0. بالظبط. Okay? j minus minus is equal to 0. 0 only, okay? And then, now the loop. Continue the loop. If j is greater than 0, no, actually j is 0, then the loop is now finished, terminated. I go and execute the statement. So a of j is equal to next. A of j is equal to what here? A of j, huh? What was the last value for j? What was the last value for j? Here we go. Huh? 0. Okay. So a of 0 is now equal to the value of next. What was next, girls? Next was equal to 5. So a of 0 is equal to 5. And that's it for the first round of my loop. You have seen what we have done? If I now go up here, so the first round, the result of the first round is عملنا ايه? A equal to, here the 5 is now at position 0, the 17 is at position 1, and then we still have what's left. We have still the 3 and we have the 9. Now, is this okay? Are everyone's following? Any questions? Dalal, you have something? Clear? Okay, perfect. So everyone is clear about that. I have feedback of 2 now. What about the rest? Zahra, Aisha, okay. Alright. When I say please, everything is clear or following, then check the mark because I'm counting the marks, so it's better for me. Okay. All right. Now, where are we now? I need to go now to the second iteration. So I plus plus. So I is equal now to what? I was equal to 1. So now I am in 2. Okay. Now, in next equals a of I. What is the value at the position of a of I? A of I is what? A of 2. Huh? What is the value here? You see what is the value here? 0, 1, 2. So what is the value now? The value is 3, exactly. So next is now equal to 3. You see, I'm starting from where? I'm starting from the unsorted part. Now, what shall I do before just thinking about the code? As we agreed, whenever I insert a new value, I compare it with what? I compare it with the value in the previous position. That's it. So first, I'm storing the 3 in my the value of 3 in variable next. I'm also storing the position of 3, which is j equals what? It's equal to here. Okay, and then I am making my condition. While j is greater than 0, yes, of course it is greater than 0. And if a of j minus 1, now a of j minus 1 is what, Jama'ah? What is the value of a of j minus 1 now? J was what? 2. 2 minus 1 is 1. So what is the value on a of 1 now? A of 1, huh? Exactly. Yes, Dalal said 17, Omnia said 3. Which one? Again, concentrate. 17. I'm looking at which array, Omnia? At the array in the last round. 5, 17, 3, and 9. And j was 2, so 2 minus 1 is 1. A of 1 is here 0, 1, so 17. So the value of a of j is 17. Okay, Omnia? Okay? Alright. So we continue here. Now, my question was, is 17 greater than next? What was next? It was 3. Yes. So the condition here is true. J is not equal to 0, and 17 is greater than 3. You know what this means? You know what this means? 17 is greater than 3. Okay. So I have to go here and execute the statement. So now a of j, which is 2, is equal now the value in a of j minus 1. So now a of 2 is equal to what? You see what happened to 17? It's moved even more up. So a of 2 is now equal to what? Equal to 17. Everyone's following? تاني أقولها تاني. A of 2, okay, which is what? J is equal to 2, right? And is equal now, we'll have to take the value that stays in the previous position. What is the value in the previous position? Huh? J minus 1. Where is J minus 1? 2 minus 1 is what? 1. So here it is 17. So now A of 2 will be 17. Okay, Dalal? Now, you see what I'm doing, Jama'ah, with the larger value? If the value larger, I keep, it's like shifting it up and up and up. Now, when I compared it with the 5, the 17 was large, so shift it up. When I compared it now with the 3, it's larger than the 3, so shift it up. So it will take the position of 3. Okay? Dalal, are you following? Okay, perfect. So I will continue now. Now j minus minus. What was the value of j in this round? It was 2. Minus minus means that j is equal to what now? Huh? 1, right? Okay, so now I will continue my loop. Is j equal to greater than 0? Yes. Now, what about the value in a of j minus 1? J was equal to 1. This is the last value. 1 minus 1 is equal to what? Hmm. 1 minus 1 is equal to what? 0. So a of 0 is the value. What is the value of 0 now? The value in 0. In my case here it is 5, right? Here the 5. So you see what I did? First I compared the 3 with the 17. I found the 17 is larger, then please shift it up. Now I'm comparing what? The 3 with the 5, with the one before. I found what? I found that it is greater than next, so 5 is greater than next. Then go and make the 5a move up. So a of j, which is what? J, the last value of j was 2. So a of 2, sorry, the last value of j was what here? It was 1. I'm still in the loop, okay? So a of 1 now is, okay, equal the value that lies in a of 0, which is 5. So a of 1 is equal to 5. So you see what I did with the 5? It's moved up in the position, in the next position. Now j minus minus. So now j is equal to, again, to 0. So go out of the loop. And a of j, which is what? Again, I'm at which position, girls? I'm at the position of 0. So now who will be in the position of 0? The value of next. What was the value of next? 3. So you see after this round, so this is the first round, the second round, here we go, a is equal to, you see what happens? Who is at position 0? 3. So I'm putting the 3 here. Who is at position 1? 5. So I'm putting the 5 here. Who is at position 2? 17. So I'm putting the 17 here. Who is at position, no, that's it. And then we still have the 9 left. Then you go through the third round, etc. until you finish it, and you will get the sorted array. Now, is it clear for everyone now? Is it clear for everyone? Is it clear? Okay, perfect. Now, one important. Now, if I want to test this, here we go. As we did yesterday, I will have my insertion sort demo. Here we go. Again, a class called insertion sort demo. It has a main method. In this main method, okay, I am calling the array util. Okay, what was the array util? Again, it's a class that we have explained yesterday. We have defined this class yesterday. In the array util class, the main usage of this class is that it generates an array with random numbers. So we use the class called random that is inherited here, okay, from the Java library. We make an object called generator. Then we have a method called random int array. Random int array. It takes two variables, the length of the array and the range of numbers that I can put. So if I put, for instance, 100, this means it will generate random numbers from 0 to 100, or from 0 to 99 exactly, okay? Then I will create my array. So int a equals new int. It will take the length that is passed here. Then it will make a for loop, okay, with the length of the array. And then in each position of the array, I will call the next number from the random generator. That's it. Once it's done, it will return the array. Please make sure there is no brackets here. If there are no bracelets for the for loop here, so this means it will. This is the only statement that belongs to the for loop. Once it's done, it will go to that one. So as if I'm doing that. So in case you have only one statement for the for loop, either you put the bracelets or not, no problem. Okay. Now, Noor had a question. She told me why here we call the what does static mean? I explained it yesterday. Static means that it belongs to the class. So whenever we are used that when from any class we can create objects, and then we can for each object we can give the values to the properties and the methods. Okay. Now when I call something static, this means it belongs to the class. So when I call, if I want to call it, as we did here in the insertion sort demo, I just say arrayutil.random int array. I don't need to make an object of arrayutil. Now the second question is the random class. Again, why is it called static here? Because I have created now a method that is of type static, and in order to use any class in order to work in a static method, everything has to be static. So if I'm now having an object called generator and I'm using it in a static method, this object also has to be static. In other words, here we go. This is the rule. If you just click here, cannot make static reference to the non-static field or generator. Generator is non-static, and we are here in a static reference. So the object here has also to be static. Okay. Now if I go to the insertion sort demo and I run it here we go. I have called my random int array. The array length is 20. It takes 100 as range of numbers. It's printing it. Here it is printed. So random arrays. Then I'm creating an object of my insertion sorter class. It's called sorter. I'm passing the array A to the constructor, and then I'm calling the method sort, and then I'm printing again the array. Here we go. It is sorted. Now is it clear, everyone? Is it clear? Okay. Now one important thing. This is a very important note here. The insertion sort is an O(n) square algorithm, so it has the same order of efficiency as selection sort. So if you double, for instance, the data set, this means it will take 4 times to process the data set or to visit the array. If you triple the data set, then this will take you 9 times. Okay, so it has the same efficiency as the selection sort. I think we're done now. Now we go to our PowerPoint, and we go to another method called merge sort. Okay, the merge sort is very simple. Okay, it sorts the array by cutting the array in half. Now assume you have an array, so you cut it in half, and then each half, and you keep cutting each half into more halves, and then once you sort or you merge the sorted halves. I'll give you a simple example. Now, first, why is it called merge? Imagine you have this array, okay? And imagine that this array is also sorted, okay? So you separate or you cut this array into 2 halves. This is the first part, and this is the second part. Okay. Now, once you have 2 halves, 2 sorted arrays, as if you have 2 sorted arrays. So here we go. I have the 5, 9, 10, 12, 17, and here I have the 1, 8, 11, 20, 32. Now I need to merge them into a one single sorted array. So I will do what? I will compare always the value here at the beginning, okay, with the value here at the beginning. So the value at position 0 here and the value at position 0. Now is 5 given what, girls? Given that both arrays are sorted. So here this one is sorted and this one is sorted. So I compare 5 with 1. Which one is greater? Which one, sorry, is smaller? The 1. So I put here the 1. So now the 1 is out. Now what are we left with? The 5 and 8. Which one is smaller? The 5. So I put here the 5. So 1 and 5, and the 5 now is out. So now I have here 9 and 8. Now which one is less? The 8. So I have put here 1, 5, 8. The 8 is out, and I still have the 9. So which one is less again? 9 or 11? 9. So I put here 1, 5, 8. Here I put here the 9. 9 is out, and I'm left with the 10 and 11, etc. until you finish. Okay, is the merging, it's very simple, girls. Is it clear, everyone? Is it clear? Okay, perfect. So now we go to right away to implementation. Here we go. Merge sorter. Now, again, I have a class called merge sorter. I'm declaring an array of type int. I can declare my constructor. This constructor initializes my array by taking an array parameter called an array. This is passed to my array A. That's it. And then I have my method that is called sort. Here we go. The method sort. Now, remember what we have said. We said what? We said I will, given that I have two sorted arrays, given that we have two sorted arrays, given that I have one sorted array, so I will do what? I will cut it into two halves. Now, how do we cut an array into two halves, as we did here? This is the PowerPoint. I'm cutting into two halves. If I have an array A now, how do I cut it into two halves? I will call the first half as first. I will call the second half as second. Okay? So int square bracket first and int square bracket second. Now, the first array will take what? In order to cut anything into halves, I will divide it by 2. So the first array will take, just focus please here. Now I'll go back to my PowerPoint. It will take the values from position 0 up till what? If I cut this array into halves, so if these, for example, are 8 elements, imagine these are 8 elements, so 8 divided by 4 is, 8 divided by 2 is 4. So I have 2 arrays of length 4. So in the beginning I will take, starting from 0 up till, up till what? Up till 4. Okay, let's see. Alright, so from the int first equals new int. Okay, the length of the first one is A. Now we declare first the length. So A of length divided by 2. Alright? Now what about the second? What is the second of the length of the second? Is it still A of length divided by 2? Someone would tell me yes, of course. But what if, girls, if I have an odd number of elements in my array? So for instance, if I have 8, if I have an 8, so this one will be 4 and the second one will be 4. But if I have a 9? Okay, 9 divided by 2 is what? Is 4.5. Type. This doesn't make any sense, so in this case, I will make an array of 4 elements and the second array of 5 elements. Okay, so to account for all cases, odd and even number of elements in elements in my array, the first one will always take the odd number, the even number, which is the length over 2, and the second one will just take the rest of the elements. So A of length minus first dot length. So in my case here, if it's 9 over 2 is 4.5, so 4, because this is an integer. So the first array will be of length 4. Then 9 minus 4 will be 5 elements. So this is the length of the second array. Everyone's following? Everyone's following? Okay. Perfect. So now, what do we need to do? Now I have declared 2 arrays, but first and second, and still these 2 arrays are empty. So I need to do what? I need to copy the elements in my array A into first and second. Okay, so copy the first half of A into first array and the second half into the second array. So here we go. We'll have 2 loops. The for loop, the first one starts from I equals 0. Now, where will we stop? Where will we stop in order to copy all my elements in the first array? Up till the length of first. So keep looping until you reach the position, until you reach the first dot length, until you, of course, less than the first dot length, I++. And then first of I is equal to A of I. Everyone's following? Is it clear for everyone? I'm just copying the elements from one array to another, but up till a certain point, okay? Now what about the second array? My question is, where are we starting from? Or where shall we end? Okay, we will start from I equals 0, okay? And we'll end up till second dot length, I plus plus. Now, I'm starting from I equals 0 because I have an empty array called second, and I will start copying the elements starting from position 0 up till the end, up to second dot length. Here we go, so second of I equals what? Now which element I shall start from which position in A? I will start from the last position I have stopped at. So I have stopped at which position? At first dot length. So I will start now from A first dot length plus I. In the first round, I is equal to 0, so I will take the value in position. If it's, for instance, an 8-element array or even a 9-element array, so I will start from position 4. Okay, I will take it. Then 4 plus I, if I is equal now to 1, then 4 plus 1 is equal to 4 to 5. So I will take the value from position 5, etc. Until we reach what? Second dot length. Is it clear, everyone? The copying is clear? Okay, all right. So now we continue. Now, up till now, I have split my array into two halves. I have copied the array in the first half and in the second half. And what shall we do now? I need to merge them. But remember what I told you? Remember what I told you? I have to make sure that these arrays are sorted, right? Or else it wouldn't make any sense to merge them before sorting them. Now, remember the recursive method? We are using it here again. Now, I have an array called first, so I'm making an object called, I'm making a new object of merge sorter again. Now, what is the class name here? Merge sorter. So I'm making a new object of merge sorter. First sorter equals new merge sorter, and I'm passing the array, the first half of the array. And then I'm also making another object called second sorter, and I'm passing the array or the values in the second of the second half of the array, which is called second. Now, what shall I do? I will call again first sorter dot sort, second sorter dot sort, and then once we are done with the cutting here, I will merge them. Now this is the question. Now this is very important here. You see what I'm doing actually? I will give you a very simple example here. Assume I have the following array values here. A is equal to 2, 8, 10, 4, 9, 6, 8, 7. As you can see here, this is not sorted, right? Okay. Now, if I cut them, if I go with my tracing, if I cut it, I will get 2, 8, 10, 4, and into two halves, and 9, 6, 8, 7. Are these sorted? Are these two sorted arrays? Are these two sorted arrays? No. Type. What are we going to do? In order to sort them, I have a very good terminating point. I know if I keep cutting each half I get, so if I keep splitting this into two halves, 2, 8, and 10, 4, I will get now the 2 and 8 and 10 and 4. And then if I cut the 2 and 8, I will have 2 and 8. Is one single if I have one single element, is it sorted or not? If I have only the value of 2, is it sorted or not? If the array is of size 1, which means it has only one value, then this array is sorted or not? Is it sorted? Everyone is clear? Everyone's agreeing on that point? If I have an array of size 1, so it has only one element, is this array sorted or not? Of course it is sorted. Of course it is sorted, okay? So, in order to reach an array of size 1, we keep cutting the array into halves and halves and halves until we reach one element. Once we reach the one element, okay, then we are sure that this one element is sorted, and we merge it with the other element that is its second half of the array. I will show you now. Remember, I said what? If A of length is less than or equal 1, return. So this is the terminating point of my method. And I will keep calling this method, which is sort, okay, where my array will be kept splitted into two halves until I reach an array of size 1. Once it's of size 1, then return the method, okay? Once the method is returning, what will happen here? Remember when I had the first copy of my array, the first half is copied in the first sorter, and the second one is copied in the first sorter and the second sorter. Now, when I come to this point, I will call first sorter dot sort again. And I told you in recursive methods, I cannot execute the statements below until I finish this part. So when I call the first sorter dot sort, it will call the method sort again here. It will create two other arrays. It will it will cut my array into two halves again, okay, and will continue and will again call first sort dot sort. So the first half, or the first, if I have now an array called x is divided into x1 and x2, then or x first and x2 and x second. Then I call again first the sort method. So the x first will be cut again into two halves, into x first again and x second. So, and for the first half again, I will call the sort method, etc., until I reach what? One element. Okay? Is it clear what I'm saying? Is it clear? Everyone's clear about it? I will just do the tracing now in 2 minutes, but is it clear for everyone? Okay. So let's have my array here. Now assume I have the following array values: 2, 8, 10, 4, 9, 6, 8, and 7. This is not sorted. Now the first thing that I will do, I will call my sort method. You see what happens in my sort method? First thing is to do what? Create two arrays and copy the first half of your array into the first part, and the second, and create then the second half of your array. Here we go. So once I call the sort method, I will have now two arrays. One is called first, and one is called second. After each step, I will ask you following, and check the mark, please. Following. Okay. Now I have two halves. I have two new arrays. Now what will I do? Just keep tracing the code here. After I have the two halves, I will call again the sort method for the first part and for the second part. But since I'm calling the sort method first for this first array, or for the first half, so I will execute this first. So here we go. When I call it, what will happen? It will take my first here part, and it will again divide it into two halves. It will divide it into what? 2 and 8 and 10 and 4, right? 2 and 8, here we go. So this is the 2 and 8. Again, on the 2 and 8, which is the first half of this array, okay, I will call again the sort method. So I will get what? Now I will get the 2. Alright. Is 2 sorted or not? It is sorted. And I will call, and now I can call the recursive call of the sort method now on which value? On the other value, which is 8, and 8 is sorted. Now can I do the merge step? Yes, here we go. Once you call the first sort and it's done, then you can call the second, and then you can merge the first with the second. In this step, what we did, and remember, I cannot execute a statement, okay, after recursive call until the recursive call is totally completed. So what happened here? I kept calling the sort method on the first half always. So 2, 8, 10. The first half is 2 and 8. Here we go. Then the first half of this is 2. Now 2 is sorted, so the method is returned. Now I can go to the second half, which is 8. If I find it is one element, so it is sorted. Now I can merge them. So now I have 2 and 8, they are merged. How do I merge them? Which one should be in the first position? The 2 and then the 8. So this one is merged. Now, do you remember what was the second half of this math array? It was 10 and 4. So 10 and 4, now I will make a recursive call on them. So the recursive call of it will be, I have 10, then I will find out that 10 is sorted, then I have a recursive call on the second half of this array, which is 4. So 4 is sorted. Now I can merge them. It will be 4 and 10. So now in this step I have 4 and 10. And in this step I have what? 2 and 8. So these are 2 arrays. Again, please merge them. So it will be 2, 4, 8, and 10, etc. And the rest will go for the second half, which was the 9, 6, 8, and 7. Is it clear, everyone? Is it clear? Okay. So if now we go to the PowerPoint. By the way, you are expected, or you might be asked about such a question. I'll give you an array and tells you, tell me how this array is sorted, as it's mentioned here. As it is mentioned here. Manually run the merge sort algorithm on the array, whatever. So you are expected to be able to do that. If you read the PowerPoint, if you go back to our recorded session, you will be totally fine with it. Okay. Now the performance of this algorithm, which is very important. Just a second. Where are we? Yes. As you can see here, if I compare the merge sort with the selection sort gives me a parabola. Here we go. So it's getting slower and slower, while the merge sort is much faster. Do you know why is it much faster? Because each time I keep cutting my array into 2 halves. I don't have to visit each element on its own, like I did with the selection sort. Okay? And if I want to know the number of visits, I'm visiting my array if I use the merge sort, do you have a clue about that? No. If I have an array of size n, now how many times do we visit my array? Okay, in the case of dividing my array into 2 halves, how many times? I visited one time in order to create the first half, and the second time in order to create the second half. So these are now 2 visits for the splitting of the array. Is it clear? Is it clear? Okay. Okay. Yes, you said 4. All right. Type. Now, how many times do I visit it when I do the merge process? Okay. I know that I have now 2 arrays, and I have now my the 2 halves, and I have now one array, which is the A with the long one. So what I'm doing, in each cell, I'm visiting each element of my array A, which is the original one, and I'm putting in this element either a value from the first array or a value from the second array. So how many times here now? How many times are these? I'm visiting the array. In the merge process, I'm visiting the array itself in order to put the value in it, each element. And I'm visiting the first half of the array, and I'm visiting the second half of the array. So how many halves? How many halves? Huh? How many visits? It's 3 visits. 1 for the array, in which I'm putting my value. 1 for the first array, where I'm comparing the first array with the second array, and so these are again 2. So 2 plus 1 are 3. So 3 visits in the merging process and 2 visits in creating the 2 halves or the 2 sub-arrays. So total is of 5 n visits for each element in the array. Now this is a simple equation that they are showing to you in order to reach the conclusion, which is my main thing here. that the graph of my algorithm is big O notation, n log n, n log n. Okay, what do you mean by n log n? Now, you know that log n is, now this is a question, log n is smaller or greater than n square? Which one is growing faster, n square or log n? Which one is growing faster? Exactly, n square. Log is always smaller than the power. The log is always smaller than the power. So you see, the efficiency of the merge sort algorithm is n log n. Okay, girls? So now to conclude, selection sort is n square, merge sort is n log n. So the n log n grows much more slowly than n square. Now there is one thing I think I have forgotten to tell you about. You see, up till now we have sorted my arrays, but when I kept calling the merge, and we haven't explained the merge. The merge is very simple. Just read it, please. It's very, very simple. Okay. Remember the merge. This is how it looked like. I'm having now two arrays, and I'm merging them by comparing which value is less. Okay. So this is how it looks like. Now, I'm doing I'm having a method called merge. Okay, it takes two arrays, or the two halves, the first and the second. Now I'm declaring a variable called I first, which represents the position in the first element in the first array. I second represents the position in the second array. J equals 0. J represents the position in my original array, which is A. So if this is first, so this is J first here J second, and this is the J of my original array. Okay. Now I make sure that I first is less than first attempt, so I haven't reached the end of the array, and also the I second haven't reached the length of the second array. Then I'm making a simple condition. If the value in I first, okay, of the first array is less than the value in the I second of the second array, then please take this value and put it in A of J, and then increment what? The I first. But if I take the value from the second array, so I will increment what? The I second plus plus. And by all means, if the value if we have put a value in my original array, then we are incrementing the array A, which is the position of array A, which is J plus plus. After we finish, sometimes we find that I still have some values in first or in second. In that case, if still I haven't reached the end of my the end of my first array, I will take the rest of the values and put it in my array A. Same wise for the second array. If I haven't reached yet its length, then I take the rest of the values and put it in my A array. Okay, is that clear? Because we have just missed to explain that part. Is it clear, everyone? Is it clear? Okay. So I have put here a question for you. Please make sure that you read this question, and I have put the answer. Okay. This will help you again in answering the first question in your assignment. This question is already put in your chapter and in your PowerPoint. So it just compares the selection sort with the merge sort. And it shows you how to calculate it. Okay, that's it. I think we're done now. Any questions? Okay, thank you very much all. And please make sure that we will continue the rest of these things next Monday. Okay, we'll continue the linear search. And I will stop recording now. Recording stopped.